So today we're starting shape and measurement. So as I said, we've done a little bit of the trig, which is all the triangle stuff, but we're going to go further and do some of the other shapes. But in this first chapter, we actually are continuing on with our trigonometry a little bit, and we're going back. We didn't do a lot of this, but we are doing Pythagoras in our first lesson here. So Pythagoras is when we have a right angle triangle and we are using all three sides of the triangle, and we know that the side opposite the right angle is known as the hypotenuse, which we in this instant we're labeling it with the letter C. So we know that Pythagoras, we've done this before, we've got a formula that says if you square the hypotenuse side, it would equal the other two sides squared and added together. So there's our basic rule. So down here they've asked us in our question to calculate the hypotenuse. So you can see they've labelled up the C there. So they've already labelled it. So we might label the other sides A and B. So calculate the hypotenuse. So we should always write our rule out first. If you write your rule, we can see what you're trying to do. If you make an error somewhere else, then you don't lose all your marks. Okay, then we're going to substitute in, very similar to like what we've been doing. But remember that C squared equals. So we're going to do 4 squared plus 10 squared. Now, because we have an equation, so because I have an equal sign there, with just one letter I don't know, our solve function would work here. So we can do that, comma, C. Now we're going to get two answers. Which answer are we going to take? The positive, because we can't have a negative length on a triangle. It will always be a positive number. So let's pop that into your calculators and make sure you get the right thing. And we're noting it says 2 decimal. Okay, so if you pop that into your calculator, remember it's comma C, you may get the exact answer. Remember, just control enter will give you the decimal answer. So I get 10.77 because 2 decimal places, because the third one was a 0, and this is a length, so I'm going to write centimetres and I'm going to pop a box around my answer. Okay, with this question, it says calculate the unknown length, so they've labelled it X. So what we were going to do is we'll label our triangle, sort of like what we've been doing anyway, but I'm going to call the hypotenuse C, and then I'll call the other two sides A and B. Doesn't matter which way they get labelled, but C must be on the hypotenuse. So then I'm going to, because I'm trying to find the side length, I'm going to write the formula. So Pythagoras formula, A squared plus B squared. Then we're going to substitute in. So C is actually 11, A is 4.7 squared, and B is the X squared. So we're going to do solve, and we're going to go comma X because it's what we want to find out. Do that on our calculator. We're reading what it says, correct to 1 decimal place. 1 decimal place is X equals 9.9 because it was a 4, and this is measured in millimetres. So I'm going to write millimetres and pop a box around my answer. So a helicopter hovers at a height of 150 metres above the ground and is a horizontal distance of 220 metres from the landing pad. Find the direct distance of the helicopter from the landing pad, correct to 2 decimal places. So sometimes it definitely helps when you have a worded problem to draw the diagram. A quick little diagram. So we've got a helicopter and it's hovering 150 metres above the ground. So we've got 150 metres. And it says above the ground and along the horizontal distance of 220 metres from the landing pad. So say the landing pad's over here. Here's the landing pad. And we're going to say that is 220 meters. Okay, so they want to find the direct distance. So when they say direct distance, it's when you join the two up. So this is the question. This is x. So I might say x equals the direct distance. Okay, and we've got to make sure when we use Pythagoras' theorem, so we've got a right angle triangle here, we have to also make sure the units are the same. So this is 150 meters and that's 220 meters, so that's okay. So they need to be in the same units, and then we should label up our triangle. So we go, this is C, and then our other two sides can be A and B. Then we're going to write the formula, so C squared equals A squared plus B squared. So your formula sheet from trigonometry would still work here. You would say, have I got a right angle triangle? Yes. Do I have an angle? No. So we'd be using Pythag. All right, we're going to substitute in. X is x squared, and then A is 150 squared plus 220 squared. So we can just pop in solve. We only want to know what one x is, so we go solve x. Sorry, that squared's a little bit, not little. Okay, do that. Okay, before we write our answer, go back and check what did they want. They wanted correct to 2 decimal places. So when I'm writing I found x to equal 266.27. So how far? It is 266.27 meters from the landing pad. Okay, with this next example, this is going to be from exercise 10B. So this is when we're going to get into 3D shapes. So when you have the 3D shape, you have to try and find the right angle triangle within the shape when we're trying to find this. So the first one I'm going to do here is it says find length AC. So AC, if you look across there, is across the bottom. Okay, so it's across you might want to write that. It's the diagonal across the bottom of the box. So this will help you so you can see what you're talking about. So you got the diagonal across the bottom of the box. So what you're going to use is you're going to use this triangle that's here. This triangle at the bottom there. So what it's always good to do is to draw out the triangle, the right angle triangle you're going to use. So if you have a look, I'm saying so we've got this, the purple line going across, we've got A and C, and what we're going to use is we're going to use out to B. So in there, along the floor, if that was on the floor, that will create a right angle triangle. That's in the corner. So you can see between A and B, it's 5 centimeters, and also see that one's 5 centimeters. Now, and also when they say it's a cube means that all sides are the same as well. So you should, even if they didn't say, if they only gave you one length, you should know all the side lengths are the same. Okay, so we're asked to find the diagonal. So we're going to call that one X. So across the bottom there would be X. So let's label it up. This would be side C, and the other twos would be A and B. We'll write the rule, C squared equals A squared plus B squared. We'll substitute in X squared equals 5 squared plus 5 squared. And we're going to just use the solve, comma X. Okay, so it says to 2 decimal places. So I've got X, when I did that, X is 7.07. So we probably should write the final answer. So they said AC is 7.07 centimeters. Now, we should remember too that the hypotenuse, so maybe make a little note there, that the hypotenuse, or the C, so we might say the hypotenuse or the C value should be the largest, yeah? So when you check that, we know the sides were 5, so we can check that 7, yes, it's bigger than 5, so I've calculated that right. I've done something right. If I know I'm finding the hypotenuse, that number's got to be bigger than the 5. Okay, so then that was that triangle. The next one they're going to ask me is this AD. Okay, so AD is the diagonal going from the bottom corner up to the opposite top corner. So it's actually within the box, and often you'll hear the question of like, what's the largest like pencil you can get into this box, or they might say a straw is going from the bottom corner, what's the largest? And this is the largest combination, where you go from the bottom corner to the opposite top corner. So what you're going to do is you're using this triangle in here, which is a right angle triangle. So just to help you draw it out, so what we've got is A to D, and then we're using the line that runs across the middle. So what I'm talking about, that is actually A to C. And you can see this is the height of the box, which is 5 centimetres, and then you're running across AC here. So you just found out what AC, because you can see in our diagram we called that X, yeah? So we already know what that is, so we might pop that in. We've found that's to be 707. So we needed to find that bottom one before we can get this one on the top. And now if we label, so we've got this right angle triangle here. If we labelled up this triangle, what we're trying to find, I might call this one Y now. So I'm calling that one Y. So we're labelling up, that's the C, this is the A, and this is the B. So if we write the formula out again, and then you're substituting in, it would be Y squared equals 5 squared plus 7.07. So this is another hypotenuse. So we would hope to see that it's bigger than 7 when we calculate it. So let's have a look. Do that one on your calculator. So we get 8.66.
8.7.
No, 8.66. Oh, it's one decimal place. Good, thank you. So 8.7, because it was one decimal place. And that's centimetres, but we should probably write out our answer that AD equals 8.7 centimetres, and we'll pop a box around it to show that's our final answer. Okay, so the next one, we've got a pyramid shape, and they will say, when they write in the question, a square-based pyramid. So this is only when there's a square on the bottom, which we can see. Okay, so first of all, they're asking me to find the length AC. So what I'm going to do, it's the length across the bottom. So I'm going to use this bottom triangle here. That's the actual right angle triangle. So if I drew out that purple triangle like this is AC going across the middle, and here's B. So actually in there is where the right angle is. So we can write out, now it said it's square base, so these two are both 25 centimetres, and we're trying to find, I'll call this one the AC, I'm just going to call it X. Alright, so off we go, we write the formula, we'll label our triangle, so X is C, and the other two sides are A and B. So we'll write our formula. We're going to substitute in X squared equals 25 squared plus 25 squared. We can pop in solve, comma X, and we're going to find out what X equals. Okay, so it ends up being 35, says to 2 decimal places, so 35.36 centimetres. So maybe write an answer of AC equals 35.36. Okay, so the next question is we want to find EF. So EF is here. Okay, so this EF is we're going to use, what we're using is this triangle, it's in here. So it's actually going down the center of the, so it's actually going down the center of the pyramid. So if you look here, this red line, if I draw it like that, here's the red line, E and F. And then what we're going to do is we're going to go out to A. So we're going out to A, and then we're joining them up like that. Now, they're saying between A and E is 26. So you can see that's 20 centimetres. If you look between A and F, that's along here. And if you look, F is actually sitting halfway between your A and your C. So what we're going to say is half of A to F equals that half of that one. So I'll divide by 2. Okay, so we've worked out, here's our right angle triangle. So along here is AF. AF is actually the halfway mark between A and C. It's running along the ground there. So we found AC over in part A. So what I'm going to do is it's the halfway mark. So I'm going to divide it by 2. So I've divided, over here, AC by 2. And that's how I know this length here is 17, beg your pardon, is 17.68 centimetres. So they want me to find this height of the pyramid. So what I'm going to do is I'd label this triangle up. This would be my C, this would be my A, and this would be my B. So in this case, we'll write the formula out. This one, we're actually finding one of the littler side lengths. So we know it has to be at least less than what?
Less than 17 and 26.
No, not less than 17. Less than 26. Okay, so we're going to substitute in. We've got C is the 26 squared. A is H, because we're calling it the height. So H squared plus, we've got this 17.68 squared. Okay, so still pop it in your calculator. You don't need to. I just did it so you made sure that you see that's a fraction, decimal.
Doesn't matter if I do the 17.
No, we just asked that. So
I just asked that question. Sorry.
it doesn't matter which. It doesn't matter which way you put A and B. Okay, so if you've got H as your B and A is, it doesn't matter. Those two sides can be either way. All right, let's go find the height. Okay, so we got H to be 19.06. One decimal place, so I'm going to say the height equals 19.1 centimetres.
Oh, that's weird.
So we can call it, they called it EF. In your exams, they'll probably say, what's the height of the pyramid? Okay, a new home entertainment system needs to be set up in a room with dimensions 4 metres by 5 metres by 3 metres as shown in the diagram. An expensive cabling is used to wire the room from the corner A to corner G. Okay, what is the length of cabling required to go from A to E and then G to H? So you just got to follow that one. That one's pretty easy. We're just going to go from A to E. So you'd cable along the edges. So that'll be the 5. And then we've got to go to H. So plus 4. And then we've got to go up to G. So 3. That's the way they would cable it. So this cabling is going to cost a lot of money. But obviously you don't want it sticking up out inside the room or whatever. So we would add this one up. We've got 5. I'll just do it down here. So we've got 5 metres plus 4 metres plus 3 metres. So what would be the length? We would need 12 metres if we did it that way. What length of cabling is required to go from A to F to G? So A to F would be across the wall. See that wall on the front? And then we'd go across along here, F to G. So what we need, we can see from F to G is actually the same here to here is 4 metres. So we know that bit, but obviously we need to know if we're going across that flat wall. So let's work out that bit first. So let's draw our triangle. We've got A to F, and then what we're going to use is we're using this triangle in the front here. So what I'm going to do is I'm dropping F down to E, yeah, and then across to A. So E to F is the height of this room, which is 3 metres, and what's along the wall length is 5. Okay, so we need to get this value here to be able to add it up. So I'm going to use the Pythag. So this would be C, this would be A, this would be B. So I've got C squared equals A squared plus B squared. X squared equals 3 squared plus 5 squared. Let's find out what X equals. It's correct to 2 decimal places, so I'm going to get X to 2 decimal places. So it's 5.83 metres. So therefore, so you often see this written, therefore, to go from A to F to G, we would have, it's going to equal the A to F was 5.83 and metres plus the F to G, which we can see is along there, so that's another 4 metres. So that would equal 9.83 metres. So the second option of getting the cabling around, so the cable guys come along and said, well, I can go from the first option, the corner of the room to that corner across the bottom and then up. That will get me to the point I need to get to. Or we could have done this other way, AF to G, which is 9.83 metres. So which one will you want to do? It's an expensive cable. Which way do you want them to use? The second one, isn't it? Because it's going to be cost. So here in question C, if the cabling costs $9.10 per metre, which one is cheaper? So if you want to work out the total cost, let's just so we can compare, we'll go total cost equals the metres times the cost per metre. Okay, so we could have 12 metres times $9.10, which would equal, what would that be? $109.20, or we could have had 9.83 times the $9.10, which would have been 9.83 times, which would have been 89.45. So which option is cheaper? You're going to say the cheaper is the A to F to G.